Imagine a powerful force that can form entire galaxies yet remains hidden from view. This is the reality of a supermassive black hole, lurking at the center of countless galaxies, including our own. But the story doesn't end there. Recent discoveries have confirmed that these cosmic giants are not just passive consumers of matter. They influence the very structure of the universe, driving the formation of stars, shaping the evolution of galaxies, and even playing a crucial role in the creation of planets like Earth. Today, we're going to dive deep into the hidden mechanisms behind these forces and explore the revolutionary changes that are finally making these secrets known. What we discover today might change our view of the universe forever. But first, let's make sure we're all on the same page by discussing some theory. Let's start with quasars, which serve as the energetic hearts of active galaxies in the universe. These luminous beacons, powered by supermassive black holes that consume vast amounts of matter, outshine the combined light of all the stars in their host galaxies. However, in our case, a particular subset of quasars, known as red quasars, has attracted special attention from astronomers. Unlike their bluer counterparts, red quasars are shrouded in cosmic dust, which plays a key role in their unique characteristics. The reddish hue observed in these quasars is a direct effect of the dust surrounding them. This dust absorbs shorter wavelengths of light, like blue, and allows longer wavelengths, such as red, to pass through. This phenomenon not only changes the quasar's appearance, but also enhances its radio emissions, as recent studies have shown using data from the Dark Energy Spectroscopic Instrument, DESI, and the Low Frequency Array, LOFAR. A study led by Victoria Fawcett and her team at Newcastle University found that red quasars emit stronger radio signals than their dust-free blue counterparts. Intense streams of radiation emanating from the quasar collide with the surrounding dust, exciting the molecules inside and causing them to emit radio waves. This interaction is key to understanding why red quasars are more radio loud. But why are these red quasars so important? The answer lies in their age and stage of evolution. Red quasars are thought to represent a younger phase of the life cycle of active galaxies. The dust enveloping them is not just an obstacle. It's a remnant of the galaxy's past, likely formed during intense starburst events or galaxy mergers. As the supermassive black hole continues to feed, its energetic jets gradually blow away this dusty veil, revealing a blue quasar with much fainter radio emissions. This blowout phase refers to the quasar evolving from a dust-covered radio loud state to a cleaner, bluer quasar with more muted radioactivity. Observing red quasars gives astronomers a glimpse into the early stages of this transformation, providing valuable insights into the mechanisms that govern galaxy evolution. The discovery of thousands of red quasars by Fawcett's team highlights their importance in the cosmic landscape. These objects are not just rare anomalies, but crucial pieces in understanding how galaxies evolve as supermassive black holes grow. Now that we have a basic understanding, let's continue our journey and delve deeper into the concept of the explosion phase and its impact on the evolution of galaxies. The explosion phase theory offers a more detailed look at the life cycle of red quasars at the centers of young active galaxies. It is believed that this phase represents a critical period in evolution, when the supermassive black hole at the core begins to clear away the dense clouds of gas and dust that obscure it, transforming the quasar from red to blue. This theory is based on the enormous force generated by a supermassive black hole feeding on the material from its accretion disk. Intense gravitational forces within this disk create friction, heating the gas and dust to millions of degrees. This process not only illuminates the quasar, but also leads to powerful jets of energy that eventually result in the explosion phase. These jets, consisting of high-speed winds and magnetically collimated streams, act like space brooms, sweeping away surrounding dust and gas. As they collide with matter, they generate shock waves that further accelerate the cleaning process. Over time, this cleaning reveals the quasar's interior, reducing the dust content and allowing it to shine more brightly in the optical and ultraviolet wavelengths, a stage we've already discussed as the blue quasar. This theory is supported by observations made with space telescopes. The infrared capabilities of the James Webb Space Telescope, or JWST, allow astronomers to peer through the dust and obtain detailed images and data, revealing the dynamics of this explosive phase. These observations show the interaction between the quasar's jets and the surrounding matter, consistent with the process of expelling dust and gas from the galactic nucleus. These findings align with the predictions of the explosion phase theory, convincingly proving that red quasars are indeed in a transitional state. This not only deepens our understanding of galaxy evolution, but also highlights the role of supermassive black holes in the cosmic ecosystem. Now, turning our attention back to the James Webb Space Telescope, one of its most impressive discoveries has been observing the galaxy ESO 428 G14, located about 70 million light-years away. This galaxy has an active galactic nucleus, or AGN, where its supermassive black hole exerts an enormous influence on the surrounding space. ESO 428 G14 isn't just any galaxy. Its AGN is a source of intense radiation, spanning the entire electromagnetic spectrum, thanks to the supermassive black hole devouring matter at an extraordinary rate. This phenomenon generates enormous energy, making AGNs some of the most luminous objects in the universe. What has captivated astronomers about ESO 428 G14, however, is not just the intense radiation, but the discovery of shock features and the swirling clouds of dust and gas surrounding the black hole. An unexpected twist that challenges our understanding of how these cosmic giants interact with their surroundings. Previously, it was assumed that the energy heating the surrounding dust in an AGN came directly from the black hole's intense radiation. However, the JWST observations revealed something far more intriguing. The energy that heats the dust comes not only from the black hole's radiation, but also from violent interactions with jets of gas ejected at near-light speeds from the black hole's poles. These jets collide with surrounding matter, creating what astronomers now call shocks. These shocks have been a revelation. It was previously debated how AGNs transfer energy to their surroundings, but the discovery that these jets can damage nearby dust and gas to such an extent was unexpected. This discovery challenges long-standing assumptions about supermassive black holes and opens up new questions about how they affect their galaxies. The implications are profound. By detecting the interaction between radio jets and the surrounding matter, the JWST has provided a clearer picture of how supermassive black holes impact not only their immediate environment, but the entire galaxy. These jets, once thought to be mere byproducts of black hole activity, now appear to play a central role in shaping their surroundings, affecting star formation rates and the overall structure of the galaxy. Thus, the explosive phase is crucial in the complex relationship between supermassive black holes and the galaxies they inhabit. To better understand this, let's explore the feedback mechanisms that govern the interaction between black holes and their cosmic neighbors. It's long been known that many galaxies have a supermassive black hole at their center, surrounded by a dynamic and turbulent environment known as an active galactic nucleus, or AGN. In AGNs, the energy flows are driven by an accretion disk, a chaotic, swirling structure of gas and dust feeding the black hole. This accretion disk, heated to millions of degrees by intense gravitational forces, emits radiation across the entire electromagnetic spectrum. The inner regions of the disk move incredibly fast, generating high-energy radiation, while the outer edges behave more slowly. For the first time, astronomers have been able to observe the outer edge of an accretion disk, giving us a better understanding of its size and structure. Using data from the James Webb Space Telescope and other instruments, researchers detected emissions from distant quasars, providing a clearer picture of the accretion disk's vastness and turbulent condition. These findings help us measure the size of the disk and its behavior, shedding light on how matter interacts in the most extreme environments. However, the accretion disk is not the only player. From its poles, radio jets of charged particles are ejected at near-light speeds, shaped by the black hole's magnetic fields. These jets are powerful enough to shape the environment around the AGN, colliding with surrounding dust and gas to create shock waves that affect the evolution of the galaxy. These jets, in fact, can either trigger star formation in some regions or suppress it in others, regulating the growth of galaxies. This feedback mechanism, known as AGN feedback, plays a crucial role in controlling the balance between star birth and star death, effectively dictating how galaxies evolve. In addition to these jets, black holes also influence their surroundings through tidal disruption events, or TDEs. This occurs when a star ventures too close to a black hole and is torn apart by its immense gravitational forces. The process, sometimes referred to as spaghettification, stretches the star into long, thin strands, with some of the material falling into the black hole and the rest being ejected into space. Recent research shows that not all of this material is consumed by the black hole. Instead, much of it forms a huge spherical cloud of gas, which can obscure high-energy radiation, such as X-rays. This cloud, detected through polarized light, offers a glimpse into the consequences of a TDE, where a black hole's appetite leaves a lasting mark on its environment. But cosmic dust is not just a byproduct of these events. It plays a vital role in shaping our understanding of the universe. Cosmic dust, often viewed as simple debris, is crucial in the formation of stars, planets, and even life itself. Formed from the remnants of stars, this dust is composed of elements like carbon, silicon, and metals. When stars explode in supernovae, they scatter heavy elements across space, which cool and condense into dust grains. This dust eventually becomes part of new stars and planets, making it a key player in the cosmic recycling process. However, this dust can also obscure our view of celestial objects, blocking light and making it difficult to observe what's happening deep within galaxies. This is where the JWST comes in. Its infrared capabilities allow it to see through dust clouds, detecting heat emitted by dust particles and revealing hidden secrets of the universe. Looking to the future, the upcoming Nancy Grace Roman Space Telescope, launching in 2027, promises to further revolutionize our understanding of cosmic dust and the universe as a whole. With its wide field of view, it will be able to capture infrared images 200 times larger than the Hubble Space Telescope, offering unprecedented data on billions of galaxies. So, as we continue to unlock the mysteries of space, the future is more promising than ever. We are on the verge of unlocking secrets that could change the way we think about the cosmos forever. As we wrap up today's video, I'd love to hear your thoughts on these incredible discoveries. What do you think about the idea that black holes might not just consume matter, but could be shaping the very galaxies they inhabit? Could they be responsible for the evolution of entire star systems? Don't forget to leave your thoughts in the comments below, and if you enjoyed this video, make sure to give it a thumbs up and subscribe for more content like this. We're always diving into the fascinating mysteries of the universe, so stay curious, and I'll see you in the next video.